So, for those who don't know Zendesk, we started out, went live 2007, and we recently went IPO. We've of course grown a lot in order to do that, and we've seen all sorts of odds and ends of the database world. We've run all sorts of data stores. But MySQL has always been sort of our cornerstone in the persistent database store, and we've had to do a lot of work to make that scale for us and work for us. I think, interestingly, as I told Osgun, this presentation will lead nicely into what he's going to talk about, how you can have the database do lots of these scalability things for you and work with you instead of having to do the labor that I'm going to explain that we've been doing over the past 7 years. So I have like 10-20 minutes, and I'll keep this at a high level, but come find me afterwards, and I'm happy to talk any detail. Personally, I started out with MySQL back in 1999. MySQL 3.23, and the guy sitting there was actually the guy who introduced me to it. He was also the person who subjected me to Oracle 6 rollback segments and the size of those. It was a horrible time. I'm happy to hear we have much better solutions today. I have to experience that. So 2007, we went live at Zendesk. This is me and my two co-founders, Mikkel and Alexander. I'm CTO at Zendesk, which means I've been pretty much in the trenches for the last 7 years of my life, fighting all sorts of fires and dealing with all sorts of issues. Today I mostly deal with engineering culture. What's the healthy engineering culture look like? How do we find out to compromise across departments, across countries? I deal with security. We don't have that much I don't have that much database hands-on today. We currently have 4 DBAs who are doing a fantastic job, great people, all of them. So currently we're at this point, Zendesk, we have 45,000 customers, we have offices in 11 countries, we have hundreds of thousands of queries per second across our database here in 4 different data centers. We just launched this little product, which I wanted to pitch here. It's pretty, it's called Inbox, it's good for small teams. But basically, we are in a much different situation than when we started. Because back then, we were sort of like very early stage, sitting in a loft somewhere in Copenhagen, and just sort of trying to be described the startup we were. We built the first version of Zendesk in our spare time. It was running on a 1-unit rack server in a closet somewhere in Copenhagen. Not exactly how you want to host your business enterprise software. And we worked on that like 2006, 2007 until we went live October 2007. And we did that at Engine Yard. I don't know how many of you know Engine Yard, but today they're like this provider tier on top of AWS. Back then, you know, Amazon EC2 was barely happening. It was not really an option for us. So we went with Engine Yard, who had this virtual host we could get. The first implementation of Zendesk was running on a single virtual machine with 640 megabytes of memory. How far we've come since then. And these guys were great at doing operations for us. They had in-house DBAs, MySQL experts to help us with the initial tweaking and configuration. So we were initially a shared database in the very early days, and we didn't have much load. We all know it's pretty grateful to deal with databases when everything fits in memory or you don't really see any traffic, no problem. Eventually we grew with Engine Yard. We got bigger nodes with them, 4 GB database node. When things were slowed down, we had more memory. So we grew slowly all the time, managing sort of how much memory you consumed at the buffer pool level, doing I/O subsystems, being very careful and growing slowly and making sure we didn't hit the cliff somewhere. The cliff where your working system doesn't fit memory and your I/O system cannot keep up. So we grew with those guys up through 2009, where we had 5,000 customers, and we were still running a single database cluster. So we had a master and slave. This was on spinning disks. Our last setup on spinning disk was with Engine Yard. It was like 24 2.5-inch 15K RPM spindles, 120 gigabytes of memory. Those were huge machines in 2009. So that worked really well for us. We scaled slowly. We kept on top of all our performance, all our queries, using tools like MyTop, just pretty basic stuff. And then eventually we felt that we needed to be able to provision hardware faster than they could do at the time. They realized that they need to shift from their on-premise private cloud setup to an Amazon-based one. So we sort of parted ways in around 2010. At this point in time, our DBA services were entirely engineering employees, and we then got the co-name on contract. Highly recommend it to work with co-name. All right. This time was also one where, you know, when I started Zendesk, I had been working like high-end consultancy gigs as an engineer, very much back-end infrastructure oriented, focused on security, been doing lots of database work. I really thought I knew what I was doing. It turns out there's a lot more to learn. It turns out that when the internet attacks your servers, you know, really, and fills them with data and requests, there's a lot more to it. So, you know, getting really uncomfortably comfortable with this kind of stuff was very much my life around that time. We were fortunate enough to move to San Francisco in 2009, where we started hiring our first ops people and dedicated infrastructure people. And with those in-house, we started focusing on sort of, okay, we know we are running out of runway, we know the buffer pool, you know, we don't have much more memory to allocate with reasonable money, we know we're going to hit this cliff here, what do we do? So we can start having those kinds of conversations. And then in 2010, anyone know what this is? Yeah?
GPU?
All right. 2010, we moved to rack space. That's one thing, faster hardware allocation. But we also switched to SSDs for the database. This is a Fusion IO card. I know 2010 seems like yesterday, but not many people did that. You know, not many people at all did that. It was all about the NAS and the DAS and the SAS and whatever, you know. And not many people did this. And we sort of said, okay, we've been following the MySQL high performance blog. What should we do? We had seen lots of bottlenecks in the I/O systems. No matter how big a RAID we had, what do we do? So we tried these guys out. It was fantastic. You know, it was literally fantastic. It took away any I/O pain we had. An altered table in MySQL will typically be I/O bound. On these guys, no, CPU bound. It's a single-threaded thing, so just plug one CPU. These guys just hardly break a sweat. It was like orders of magnitude better. So this just took so much pain away from us and gave us sort of room to growth until we could scale out our database even further. I know today this is pretty much the standard for any performance database cluster. It's very expensive, I want to say that, but as a measure for our growth, it was absolutely amazing. What also came with these guys was not many people use them. And that means we all of a sudden started to see some issues with our databases, with MySQL, where operating on some blobs with high contentions, it would crash and not come back up. Which is freaking scary. Because all of a sudden, what you see, this is my cornerstone. This is the thing. You know, this is what I'm basing my future on. And fortunately, we had a really good contact with MySQL, then owned by Sun, by Oracle, and we got like a hotline into their support, and we gave them a case that reproduced this, and they had fixed for us, and we have a patch in there without naming it somewhere. Turns out that only us and Facebook were seeing this issue. So we had quite a bit of load, and we've perhaps been a little, you know, close to sort of the bleeding edge of technology, because all of a sudden MySQL, which was programmed on spindles, saw edge cases and race conditions that had not been surfaced earlier. So this new technology, fantastic for us, but also made us. I'll tell one little anecdote here. One night I got woken up. We had this crashing bug with this guy. And it was 3 in the morning, and we had a master and 2 slaves. The master was already down from earlier. This was this slave going down, and then 1 slave left. And so we're sitting there, you know, this is not something that you want to do ever. We're sitting there, and we had our now 2 masters down, like 1 slave left, and we're like, okay, we can't have this happen again. So I called 2 of our best engineers and woke them up. And we'd sit there, you know, on IRC and sort of figure out, okay, what do we do now? So we rewrote parts of our infrastructure in a couple of hours to make sure we did not use the blobs. We had a good feeling that blobs were somehow related to this crashing bug, so we converted that to like a varchar 10,000 instead to prevent these things from happening. And that actually worked and held things together for quite a while until we got the actual patch. But that's things, you know, you don't want to experience. You don't want to be down to your last day and knowing if this crashes. It crashes hard, and you can't just recover it, you know. And that was like a really scary experience. So since then, for like 3 years, we had 3 slaves. We never used the third slave, we had 3 slaves. You know? It was just a thing, like you just don't want that. You don't want your cornerstone to just disappear under your legs and you're like, whoa, what now? Yeah, so, but that story aside, great choice, great upgrade for us, great for MySQL. Alright, so when this guy, you know, we didn't really run into capacity issues in terms of throughput, but eventually, you know, the disk use will grow, and you just figure out what you do. Okay, you put 5 cards in, you can grade it, you can figure that stuff out, but eventually that's not going to work. It's not going to be enough. You're going to have your master writes are going to be a bottleneck eventually. You know, you do slave reads, but master writes will be a problem. So we took the next sort of incremental step, and our infrastructure team looked into sharding. So this is a really basic overview of what sharding is. Basically, on each database cluster, physical cluster of 3 machines, you have multiple shards. That means you have multiple logical databases. And an account in Zendesk goes into any one shard, and only one. That means when a request comes in Zendesk, the first thing we do is to look into the shard database, say, hey, what shard do you go to? And then we point the connection there for the rest of that connection, that request. And that works really well to scale out horizontally. It gives you one of these levers that you really like to have. You now know I can, as long as a single customer doesn't outgrow a full database cluster capacity, I can scale out horizontally. I can throw hardware at it, which is it's really nice. It's a great relief when you're fast growing. We did a bunch of open source work that we published around this, like client libraries, Ruby and Rails, that kind of stuff. One thing that comes with shards, though, is load balancing. So okay, all of a sudden this customer we put over here, like a long time ago, became this giant customer, now needs this much more resources. What do you do? So we, of course, started building. Initially, one thing you do when you shard is you make sure you have unique IDs globally, so you can at least move the record to another database somewhere else. So you know that you can balance your shards by saying, hey, I can take this entire account, move everything from this account into another logical database somewhere, and know there will not be any ID collision. So you write an ID allocator. We have a service for that. It's a guy who just asks, give me the next unique ID. You get the ID and you just stuff it in the record, you're good. Then you have this amazing ability to load balance stuff. Our first shard mover just does a simple select into out file MySQL, just dumps things into disk, copy it over, reads back from disk, and flips the DNS, and you're good. The account, of course, needs to be locked for the duration of this. It's not very sexy, it's not very fast, but it works. So with this in place, we had sort of enough stuff to, we had enough tools to sort of to scale out and to grow our infrastructure. We had enough stuff in place to take care of our continued growth, and we could onboard more engineers, and we could start looking into more things like writing tools to manage this. So one thing I just want to pitch here is MMTop, which is a multi-MyTop or multi-MySQL top. If you run many MySQL databases, it's like MyTop, but it's scriptable. You can grab with regexes for certain query patterns, like should know queries that take more than 18 seconds on this host, and you can kill them. Killing queries, it sucks, but sometimes you have to. So writing these kinds of tools became part of our DNA, and it's very much how we see the world today, solving problems at large scale. I know there are off-the-shelf tools today to solve some of this, but it just goes to show that sometimes you need to build your own solutions. Zendesk has always been slightly ahead of the curve. We've not been able to rely on EC2. We've not been able to rely on SendGrid because of price performance for email sending. We've had to build all our own stuff. I think we constantly revisit that notion, but at times we have to build, at times we have to build our own solutions here. Anyway, if you do MySQL, check out MMTop, it's fantastic. When you grow, and we expanded into many data centers as well, we currently have 4 data centers. When you grow, you need to make sure you can deal with disaster recovery and data center replication, all these things. And your system, your one little application on one little single database becomes this big, complicated distributed system. And there will be cracks, and things will fall through those cracks. And there's always have to fix those, make sure that we fix them once and for all. Sadly, I was not there that day. We had to apologize. We had some instability a couple of years ago. But it goes with the program. It's something you need to mature and get on top of as soon as you can. It's something you need to take very seriously. And for example, MySQL doesn't do online table alters natively. It didn't until sort of Facebook somewhat recently shipped some online altering tools. We had to go through all sorts of hoops to add an index, to add a column, to rename a table, all that stuff. Have to rename a table. But many operations that you would want to do online was not supported. And that would cost you downtime. Sometimes you need to schedule like an hour downtime to do a significant database migration or do a state master swap. So all this comes down to process and tooling. So one of the things we did to sort of reduce our downtime required by database maintenance was another tool, which we call Active Record MySQL FlexMaster. I love the name FlexMaster. But basically, it's just a tool for doing a fast master-slave swaps. It's just a tool that says, hey, you tell this library, it's a database adapter, you tell this library, these 4 hosts are my databases. These are my masters and my slaves, and my master and my slaves. And this tool will just say, okay, I've got 4 databases, then figure out who's the master, and it will look for the read-only flag, and make sure there's only one that you can write to, and say, okay, the slaves, I have the master. And this guy, when we go in, the DBS go in and flip the read status on the nodes, will just adapt to that. So this is another example of these kind of tools we've been writing in order to be able to scale out MySQL. We're currently working on, it's called Exodus. Gods and Kings and data transfer, which is a tool we've written recently to do like 1-2 seconds shard moves. It's a tool that combines reading from the table for a given account, what do you have here in this account, and then tails the bin log and replicates that, streaming to another database, perhaps in another data center, perhaps in another country. And that's sort of the scale we do that. We can do this like massively now. We can really rebalance all our databases at great scale. And what I want to get to is like this. I'm sure you're all thinking this. Isn't this just an awful lot of work? It is. It's hard work. It's complicated. And why don't you just use MongoDB? Why don't you just use Hadoop? Why don't you just use DynamoDB? Why don't you just go on Amazon? The thing is, it's not always that simple. There's no data store I would trust with the data I want to keep other than a relational database. Maybe Dynamo and maybe these things, but they were not available to us. But basically, we've all heard about people's pain points with Mongo. We've heard this recent debacle about Redis, you kill it and the master replicates an empty data store to the clients and it's gone. We hear these horror stories all the time. If there's one thing I want to rely on, it's my database. That brings back to this decrashing story. It's horrible when it happens, but my database should really be the foundation of my company. So yes, it's a lot of work. The fact is we've not found any silver bullet yet. I think Oscar's presentation is going to be very interesting for all of us because he's going the direction that I would go. We get offers from new NoSQL stores every day. Just put in this, just put in that, just put in this. But we don't want to be the biggest fish in that pond. We never want to do that. We want to use something tried and true. So we'll keep working and grinding and scaling up things. In our near future, we're very much looking at elastic data stores. So we know that many elastic data stores are just key value stores, and maybe we'll just say, okay, a big chunk of our application will just work on that. We will look into YouTube have this project that's called Visor, I think, which is an elastic proxy frontend in front of MySQL, which will help taking the sharding thing and the knowledge about ID allocation, take all that stuff out of the client, so away from Ruby land, into a proxy, so we can connect our Go applications, our Node.js applications, all this stuff to it, and sort of conceal the pain of scaling MySQL into this proxy. We are about to take on a massive rewrite of big parts of our infrastructure, how we do things at scale, with the same mindset. Stronger, better services with a larger responsibility. We are 7-8 years old. It's only just now we really need to do this. We could start out doing that from day one and we wouldn't have gotten anywhere. Thankfully today there are things like AWS, which will cover a lot of this. I think the price performance question on AWS still remains to be answered. There's some things there. Can you get, how much can you get from one Fusion IO in terms of IOPS, and how much do you pay for that on Amazon? I think there's stuff people need to think about, or just reduce your load of the database. All right, so that sort of rounds up my presentation. It's been a bumpy ride. Sometimes you take one for the team, and sometimes you run into issues. But it's definitely these challenges are good to have. It's been lots of hard engineering. I definitely have things like Postgres envy. I chose MySQL. It was a pragmatic choice in 2006. Done. And when you look at what Postgres can do today, amazing database. There are things like ID allocation, you know, it's just an ID, just stuff it in there. It turns out that our IDs are not, they come from a host, they come from like an array of hosts, the IDs, and they're not ordered. Which means that you can no longer just order by ID, which is just inconvenience. It seems like a little convenience, but in reality it's really freaking useful. And that also brings up another point, like if I could do everything over here, I would have big ints everywhere. I would have ID schemes based on timestamps, leftmost bits, hosts bits, and random bits, and then a counter, you know. There are things that would just make your life so much easier at scale. You just don't think that way when you're small. It's kind of annoying. Yeah, and of course, doing this again, I'm sure, you know, it would be interesting to play with RDS and see Postgres there, see how that works, but I'll leave Oscar to talk about scaling that part. So at least now I hope you understand some of the pain in sort of doing things yourself all the way. I think on the positive note, it is very positive. Things work. We're in a great position. We're in a better shape than ever. We've solved these hardware demands in many levels. We scale out by data center, by host, by servers, you know. So it's been very educational. We understand everything that goes on in the company because we did it ourselves. All right, that's it for me. I'm of course hiring. I'm looking to a slide. You should all join. You should.